Hello, it's Mr. Juvent again, or Mr. Concepts. This is the second part of volumetric analysis, and this time I'm talking about radical compounds. We have already seen about how the one atom combines with another atom in the formation of a binary compound, but now it is about radical compounds. A radical is a group of atoms. It is a group of atoms which is having its own charge and its own valence, and it acts as a single atom in the formation of a compound. Also, radical as it is in binary compounds, radical compounds, you'll find them written on the chemical containers. For example, this one is sulfuric acid container, and it is written in the chemical formula H. It is written H. You can see it is H2SO4. Now, among this chemical formula, a part is an atomic ion and the part is a radical. Now, let us see some common radicals. On the whiteboard, you can see this one is a radical called the ammonium ion. Ammonium ion. This one is called sulfate ion. Now you can see it is a group of atoms. This one is sodium, this one is nitrogen, this one is hydrogen, but all together comes together to make one thing, that is a radical having its own charge. This one is sulfur, this one is oxygen. So all together comes out with something, a radical called the sulfate. Now another common one is hydroxide radical, and this one is nitrate. Here it is having a charge of -1, and this one, hydrogen carbonate, is having a charge of -1. Now can you see? So this one is a nitrate ion, and this one is carbonate ion. This one is called the hydrogen carbonate ion. So these ones are at least some of the common radicals we find in chemical compounds or chemical formula. But then radical compounds, after these ones combines among themselves, or one atom may choose to combine with a radical, we come out with the formulas like these ones. You can see this one is ammonium ion combined with chlorine, and it comes out with ammonium chloride. This one is ammonium fluoride, hydrogen carbonate, hydrogen sulfate, and the others. Now we need to see how do these chemical formula or chemical compounds form. Now let us see how does, for example, ammonium chloride form. See, you first write as usual. You first write the positive radical on the left with its charge. Then followed by another substance you need to combine it. You combine it with, say, chloride ion. After there, it comes another step of where we convert the charges into valences. Now it is like ammonium. Now when you are treating a radical in writing chemical formula, it is more better the radicals is treated with a bracket outside, so that it will not confuse you in writing the chemical formula. So when you convert this one, at least let us put a radical, a bracket around the radical, and then we introduce the valence outside the bracket there up on the top of the chemical formula right side. And then this one is not a radical, so it will be having its valence over there, a valence of 1 and a valence of 1. The next step is to exchange the valences. Now ammonium with its bracket and the valence over there, and this one is chlorine with its valence over there. This is a valence of 1, like that. Then the exchange of valence. One from ammonia will move to chlorine and be written as a subscript over there, and one from chlorine will move to ammonia and be written as a subscript over there, but outside the bracket. And then after that, now we have something like ammonium bracket, 1 outside the bracket, and the chlorine 1 over there. Now when we bring them together, we have something like ammonium ammonium with a valence of 1, and a chlorine with a valence of 1. Now, we have said that if we have a valence of 1 written in a chemical formula, there is no need of indicating it, because when you write the chemical symbol without any number, that one is termed as 1. I mean, the atom and the atomic number, the atom is 1. So there is no need of having these numbers. And if there is no number to write outside the bracket, there is no need of having the bracket around the radical or around the chemical formula. So by that way, the final formula comes out as ammonium, 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 this way without a bracket, and then chloride. So this one is ammonium chloride, similar to this chemical formula, similar to that chemical formula. Now, this one is done already. You can try on your own that one. The next. Let's see another example. Let's see another example. Maybe assume you need to combine hydrogen and the carbonate in the formation of hydrogen carbonate. So the first you write hydrogen with its ion, positive 1, and the carbonate with its charge, negative 2. Then after, convert the charges into valences. This one brings a valence of 1. And this one brings, here a carbonate is having 3 over there. So 3 over there. Now because this one is a radical, because it is a radical, we need to introduce a bracket before we continue. This one is having a valence of 2. Then you exchange valences. Simply, when you exchange valence, 2 will move to hydrogen and 1 will move to carbonate. It comes like hydrogen with 2 and carbonate with 3 over there, and a bracket outside the bracket, we write 1 like that. See, after there, now this is 1, this is 1, and if 1 is, one appears in the formula, there is no need of indicating it. And if we don't have a number to write outside the bracket, there is no need of having a bracket. So finally, we have the chemical formula. We have the chemical formula hydrogen with a valence of 2 over there, and a carbonate with no bracket. So this one is called a hydrogen carbonate. Lastly, maybe let me have this one. So you can try, this one is done already. Now you can try this one because it is of the same nature. You can try that one. Now let us see. Maybe let us pick this one here. Let us pick that one and see. That is calcium with a charge, positive charge of 2. Positive charge of 2. And in combination with carbonate with a charge of negative 2. And then we write as a valence calcium with a valence of 2. Carbonate like that, carbonate with a valence will come with a valence of 2, like that. And then we exchange the valences. There we see it is calcium, meaning calcium with the 2, and carbonate with the 2 over there. So 2 from calcium moves to carbonate, and 2 from carbonate moves to calcium. So it becomes calcium with the 2 and carbonate with the 2, like that. Now see, 2 in calcium and 2 outside the bracket of carbonate, the numbers can be simplified. So when you simplify this, it becomes calcium with 1 and carbonate outside the bracket 1. Finally, 1 and 1 is not indicated in the chemical formula, so we finally write calcium carbonate without a bracket. So after that, you can do this. You can write that one on your own. Lastly, let me perform this one for you. Let me perform that one, for it will be the last. Okay, now let us see how do aluminium combines with the hydroxide in the formation of aluminium hydroxide. Aluminium hydroxide. How does it form? It forms like the start is aluminium with its charge of positive 3, and then on the side it is hydroxide with a charge of negative 1. So this one is a radical, this one is a simple atomic ion. Now after that, we have aluminium with its valence, a valence of 3. And we have hydroxide with its valence, hydroxide. But before, we introduce a bracket like this, and we have a valence of 1 over there. And then it is the exchange of valences. When you exchange the valences, you have aluminium, 3 over there, and hydroxide, 1 outside the bracket. Now, 3 from aluminium moves to hydroxide, and it will be written as a subscript, so over there. And hydrogen from hydroxide, meaning 1 from hydroxide, will move to aluminium over there, and it will be written there as a subscript. And then we have aluminium with a valence of 1 down there, and we have hydroxide with a valence of, meaning bracket first, then a valence of 3 down there. Then when we combine the two, 1 will not be written but 3, and then so we say it will be aluminium with no any number over there, but then we have hydroxide there, see, hydroxide having a valence of 3. So this one is what is called the aluminium hydroxide, and that is how does it form in the formation of compound. So please let me end up there. You meet me in the next part after this, part 3. Thank you so much.